Part 2. 5.2, right triangle, trigonometry. So we're still in this realm. Okay, we're still dealing with all 6 trig functions. But now we're going to talk about some identities. We're going to derive some and then start using them. We're going to approximate trig functions on a calculator. That's why I told you guys to grab a calculator. That way we can kind of crunch some numbers together, make sure we're on the right page. And in the last part, do some applications with trig. Okay, just some of them. There's a lot of applications. We're just going to touch a little bit on them, and then you'll see more as we progress throughout the year. Let's review. Okay. So 0 degrees. This is 90. What's the radian measure?
Pi over 4. No, pi.
Pi over 2. Okay.
That's what I did.
Then we turn 180 degrees. That's the same thing as what? Pi. Then we go 270, which is 3 pi over 2. And then if we go full 360, 2 pi. Bueno. Okay. 30 degrees is what as a radian measure? Pi over 6. 45 degrees. Pi over 4. And 60 degrees.
Pi over 3.
Pi over 3. Okay. So again, those ones got tattooed to your brain. You got to know those, okay? Now, last lesson, we did talk about sine, cosine, tangent, right? And what those values are for that. So hopefully, every night, try to make flashcards. Try to start memorizing that. Could you derive it every time? You could, but that's a lot of work and a lot of time, I wouldn't say wasted, but it's good to know what sine, cosine, tangent are at those 3 values, okay? All right. Enough of that. Let's, wait a minute. Oh, that is not part 2. Grab the wrong side. That is part 2. There we go. Okay. And this is just a continuation of your notes. So it's not like a separate subheading or anything like that. We're just continuing it. So given the following triangle, we can create more trig identities. Okay, so let's give it a shot. So here's this triangle. Here's theta. And this is the adjacent side, the opposite side, and the hypotenuse. Okay. So let's find some Pythagorean identities. So that's what these are called here. So Pythagorean theorem. We know that. So that's a squared plus b squared equals c squared, right? Okay. I'm going to do the exact same thing, except I'm going to use a, o, and h. Okay? And remember, this is all in respect to the angle theta. So this is the adjacent side in respect to their opposite side, and then hypotenuse, that's just for the whole triangle itself. So let me go ahead and plug these into here. So let's use o squared as one of my sides. Another side would be adjacent. Adjacent squared. C squared is your hypotenuse, so it would be h squared. That's just me putting the relationships of the side lengths in the Pythagorean theorem. Now, watch what I can do. If I divide everything by h squared, okay, what is opposite over hypotenuse? What trig ratio is that? Sine, cosine, or tangent? Opposite over hypotenuse. Sine, okay. So this whole thing, I can change it to sine squared, and we'll use theta, because that's what we use up there. So change to sine squared of theta. Okay, adjacent over hypotenuse. What trig ratio uses that? Cosine. So this transforms to cosine squared of theta. H squared over h squared is 1. There's one of our identities. Anywhere you see sine squared plus cosine squared, you can take it out and put 1 in its place. They're equivalent to each other. That's pretty cool. Any questions on how I did that? Now, what we can also do is, instead of dividing by h squared, can you see you could divide it by like o squared and a squared and come up with more identities? Let's do that. One thing to note, this right here, this is important. Okay, I want to establish this now. Okay, if I did sine of theta squared, if I were to square the whole thing, that's like me writing this. Okay, they're equivalent to each other. Okay, very important. This, I'll put a non-equal sign, is not the same. Here's the reason why. This is squaring the angle. It's not squaring the whole function. That's what this is doing. We're squaring the whole function. So these two mean the same thing, but if you do this, that's telling the reader, it's telling their calculator, hey, square just the angle, and then take sine of the whole thing, which you don't want to do that. All right, let's try some more. Let's go back to our original. So o squared plus a squared equals h squared. And the first one we divided by the hypotenuse all the way through. Let's divide by the opposite side. Let's go ahead and do that. Okay, the first fraction will reduce to a 1. Okay, let's think about this. What trig ratio deals with adjacent over hypotenuse?
Cotangent.
It's cotangent. Okay. Yeah. So square, because all those values are squared there. And on the other side, what ratio has the hypotenuse over the opposite side?
Cosecant.
Cosecant. Okay, where's that marker? So here's another identity. So here's what you can do, and this will be even more prevalent in like future lessons. If you see cosecant squared of theta, you could swap it out for 1 plus cotangent squared of theta. They're equivalent to each other. And I think we got one more identity. So I divided by opposite, divided by hypotenuse, so I should divide by what next? Adjacent side. Okay, so let's do that. Okay. And this guy, so opposite over adjacent. Okay, what trig ratio deals with that one? Tangent, very good. So tangent squared of theta, that just becomes a 1. And hypotenuse over adjacent squared, what would that be? Secant squared, very good. Okay, there we go. These are our, we would call them trig identities, or well, they are trig identities. We specifically call them Pythagorean identities because we use the Pythagorean theorem to create them. Okay, so at any point you see this statement, you can swap these two things out for secant squared of theta, and vice versa. If you see secant squared of theta, you can swap it out for this guy. Okay, any questions on that? Now, here's typically what I do. Okay, not unless I'm using it a lot. These don't always pop in my mind. This one, I always have in my mind. I always know it equals to 1. I can use this to come up with these two quite easily if I really wanted to. Okay, so for example, like instead of me using O's and A's and stuff, like if I divide everything here by sine squared of theta, okay, that becomes a 1. Okay, over here would be cotangent, and on this side would be cosecant. So do you see how I still get that over there? So if you can memorize just this one right here, you could derive the other ones just by either dividing by sine squared or divide by cosine squared of theta. Okay? So try to, I mean, again, we're at the very beginning of all this trig stuff. A lot of info, a lot of things being thrown at you. You want to try to find ways to remember how to either come up with these identities or just, memorize them. And it does get easier. The more you start using these, which we're going to be using these throughout the whole entire semester, it does become easier to recall them. Okay, let's use them. Let's try an example out. So given that secant of theta is pi over 4, or an acute angle theta, find the value of tangent of theta. Okay. Part 1 of the lesson, we drew a triangle. Remember that? We drew a triangle, and we labeled the sides. We found the side that we needed, and then we came up with a ratio. You can do that. I'm not going to stop you from doing that. But what we can do now is we can use one of these guys to figure out the answer without drawing a triangle and doing all that work. Okay? So let's go ahead and do that. So tangent and secant, is there an identity that has them both? Yes, it does. So let's go ahead and use it. So tangent squared of theta plus 1 is equal to secant squared of theta. I'm going to go ahead and plug in what secant of theta is, which is pi over 4, and then I'm going to solve for tangent. Okay? So tangent squared of theta plus 1, and then this will be 5 over 4 and squared. This becomes tangent squared of theta plus 1 is equal to 25 over 16. Okay, we'll subtract 1 over. So let's see, this will be 25 over 16. It'll be what, minus 16 over 16? We find a common denominator. So yeah, it'll be 9. 9 over 16, very good.
Take the square root.
And square root to finish. Absolutely. Okay. So we get tangent of theta is equal to 3 over 4. Now, we are talking about, for right now, we're just talking about triangles. So it uses what, a positive or negative component? So we just took the positive component. Okay? We're not quite to that point yet where we consider both sides and different things like that. You'll see later. All right. Any questions? Does that make sense? So this is an option now. Again, if you want to draw the triangle, okay, label this. So secant is just hypotenuse over adjacent. So hypotenuse is 5, adjacent would be 4. And then you just kind of work with it. You can do that, okay? Don't have to, but it's an option. Okay, let's talk about cofunction identity. So this is one type of identity. Let's talk about cofunctions. I'm going to put on this board over here. Okay. So let's consider the following triangle. Right there. Let's bring the 3, 4, 5 triangle back. Okay. We'll make that angle theta. And the other one, to figure out what that angle is, you take 90 minus that. So we'll make it 90 minus theta. And let's say I ask you to find cosine of 90 minus theta and sine of theta based off that triangle. We talked about it a little bit in the homework for a prior night. Cosine of 90 minus theta, okay? So cosine deals with what two sides? It'd be adjacent and hypotenuse, right? So here's my angle. So adjacent would be 4, hypotenuse would be 5, so 4/5. Okay, so this angle in relation to cosine is 4/5. Now sine of theta. Okay, so sine of theta is your opposite side over hypotenuse. So here's theta, opposite would be 4, hypotenuse is 5, you get 4/5. So, hey, they're the same, the absolute same, okay? So this happens when these guys are part of complementary angles, because these are complementary to each other, okay? So we can see that theta plus the 90 minus theta equals 90 degrees. So sine and cosine have the same value for complementary angles. Okay? You might have covered that in geometry too, possibly. We did talk about it, not in full detail, but I believe we did at least mention it as we were talking about basic sine, cosine, tangent. Now, this isn't the only thing, okay? If we take a look at the other trig functions, they actually behave very similarly to it. And the cool part is the names of these trig functions kind of tell you what goes together. So for instance, okay, sine and cosine. So think about it. Cosine has the word sine in it, right? Okay, so there is a complementary nature to them. Tangent would be complementary with cotangent. Okay, they're going to have the same property as what we're seeing up here. And then the last one, we could say secant is the same thing as cosecant. They're going to have the same kind of property as what we're seeing up above. Okay, so this co part, there's a reason why they actually put co there. Okay, it's because of this complementary nature that we're seeing here. They come out to be the exact same value. So let's just write an official definition with all this that we're seeing over here. Try again. For an acute angle, theta. Okay, two trig functions. We're going to call them just f and g. Are cofunctions if the following is true. Okay, step out of the way so you can copy that down. So what this is saying is, just like over here, if I had sine of theta, it's the same thing as cosine of 90 degrees minus theta, which we saw in that example. And then you can flip it. Okay, so if I had cosine of theta, it's the same thing as sine of 90 minus theta. So they're equivalent to each other. Okay. All right. Let's go ahead, and I'm going to use that example over there. Let's go ahead and write the other ones with it. So using this example, I'll redraw it over here. This is what, 4, 3, and 5. So we did cosine sine. We can see how that works out. Okay. So if I do tangent of theta, okay, so tangent is the opposite adjacent side, so that's 4/3. Okay. Now, what's a cofunction with tangent? Cotangent. Okay, so cotangent will be 4/3, but it's only going to be 4/3 when using the other angle. Okay, the complementary angle to theta. So 90 minus theta will give me the exact same value there. And the last one, we can do secant. So secant of theta, which would be 5/3, is your hypotenuse over your adjacent side. Okay, with its cofunction, so cosecant, 90 minus theta would be 5/3 as well. I'm teaching you right now is ways to substitute a trig function for another trig function. Okay? The Pythagorean identities. We can use those to solve. We can also use it to take something out and put something else in its place that might be easier to work with. Same thing here. If you had this in your equation, maybe it's easier to work with tangent. I don't know. I don't know what the problem is, but let's just say there was a problem where tangent was easier to work with. Well, because it's complementary, because it's 90 minus theta, then I can put tangent in its place and maybe work with tangents then. Okay? So those are going to be very beneficial to us. So let's just create a nice little table, a little summary here at the bottom of these properties. Give me a moment to write these down and then I'll move out of the way here. Okay, so there's sine and cosine, just showing that property. I also included the radian measure. Okay, so you could do this in radians. Remember, 90 degrees is pi over 2. So there's sine and cosine. Okay, over here I'll put tangent. And the last one's the secant, secant, cosecant. Okay, so just a little summary of all the cofunction identities that we have here. Okay. All right. Well, so I'm going to pause just for a moment. Questions as people are writing some things down. Anything at all? I'm going to, we'll put our next example over here. I don't want to continue writing on that board and be in front of people. So let's go ahead and use them. Let's try an example out. For each function, find a cofunction with the same value. Bless you. So sine of 60 degrees equals square root 3 over 2. That's one of our special angles we talked about in the last lesson. And then tangent of pi over 6 equals square root 3 over 3. I think this marker is getting close to dying here, so we're going to use a different one. Purple's nice. Use purple. Okay. So what this wants to know is there another trig value, okay, that has this same output but at a different angle? And absolutely, right? Okay, so let's think about this. So I know that sine of 60 degrees, using the cofunction identity over there, is the same thing as cosine, and it would be 90 minus 60 would be cosine of 30 degrees. Okay, so cosine of 30 degrees is the same thing as sine of 60 degrees. So I can rewrite this as cosine of 30 degrees is equal to square root of 3 over 2. There it is. Simple as that. Okay, looking at tangent, pi over 6. Okay, I'm going to do the same thing, I'm going to use the cofunction identity. So that's this guy over here. So cotangent is what we're going to be using. Oh, sorry, this one. Cotangent. So let's go ahead and figure this out. So tangent of pi over 6 is the same thing as cotangent of pi over 2 minus pi over 6. So instead of me using 90 minus, I'm using the radian measure, pi over 2 minus pi over 6. We get cotangent of pi over 3. Therefore, cotangent of pi over 3 is the same thing as tangent pi over 6, which is square root of 3 over 3. There we go. Okay. All right. Any questions on those? Does that make sense? So they're just equivalent to each other. Okay. Now, you got calculators. Get ready. I want to practice typing some of these in the calculator and making sure we get the same answers. Because here's the thing, you can be doing all the work correctly, but you might have an input error on your calculator. That would suck. So let's go and start calculating these using your calculator. Okay. So for this example, use a calculator to approximate the function values. So sine of 37.5 degrees, cotangent of 30 degrees in 40 minutes, cosine of pi over 9, and I'm out of space. Okay, we'll put it here. D is secant of 1.2. Okay. Now, one of the things I want you to check is on your calculator. Okay, notice that the first two are in degrees, right? Your calculator actually knows that there's a radian measurement out there. Okay, so what you need to do first is hit the word mode, hit the button mode. And if you look, it's the 1, 2, 3, 4th line down. Make sure degree is highlighted. If it's not, just go over to it and just hit enter. So that way degree is highlighted. That way your calculator knows you're typing degrees into it. Okay, then just hit second in mode again. You'll get back to the main screen. So we're gonna go ahead and type sine of 37.5 degrees in there. Okay, so it's like one extra row above the numbers, you'll see sine, S-I-N. Type in 37.5 and then hit enter. So hopefully we all get the same answer here. Okay, I got 0.6088 if we round. Okay. What do you think? They were shaking their heads. Nope. Didn't come out the same. Alrighty. Now, next, let's do cotangent. Now it is in degrees of minutes. I tried working with some of the calculators here. There is I believe there is a minute button on your calculator, but to access it and do everything else, it's a lot of steps to memorize. So here's what we're gonna do instead. Here's what I want you to type in your calculator. Cotangent is the same as 1 over tangent, right? They're reciprocals of each other. So in your calculator, we're gonna do 1 over tangent. Now, if I were to convert this to normal degrees, it'd be 30 plus 40 times 1 over 60, right? That's how we do our conversion. So in this set of parentheses, we do 30 plus 40 over 60, okay? again, I was working with it. To me, I didn't like it. There was a lot of different things to do, so we're just gonna do it this way. So 1 divided by tangent 30 plus 40 over 60. Okay, and we get 1.6864 if I go to 4 places like that. Okay, what do you think? We okay with that? Awesome.
I like that.
No?
No, it's probably fine. I'm just busy writing that.
Oh,
and
okay.
The
Gotcha.
example.
Now, I want to point this out to you as well. For instance, over here, sine of 60 was equal to this, right? Your calculator is not going to give you the fraction version of it. I mean, I'm sure you can convert it yourself. It's going to give you the decimal version, right? That's what this is. This is a ratio of 2 side lengths. They just give you the decimal and the fraction. Okay, so any questions on the degree side of things? Pretty easy, huh? Okay, radians. If you see a pi, think radians, right? Okay, so go back to mode again. Go down to radian and hit enter, so it's now highlighted. Then hit second in mode to get back to your original screen. So now you're in radian mode, so your calculator knows that, oh, we're not doing degrees anymore, okay? So now in your calculator, let's type cosine. Now the pi button should be okay with this, but in case you're not sure where it's at, if you hit the second button, it's this up arrow. People call it the caret symbol, right? It's above the division symbol. You can hit that, and then divide by 9. Okay. And for this one, 0.9397, if I round down. Okay. And again, I mean, that is a ratio of 2 sides. Last one. Now, there's no units with this, right? There's no pi there. But if there's no units there, we assume it is radians. Okay, if it's degrees, you'll see the degree symbol. So this is still radians. Now again, there's no secant button on here. So what you're going to do is find the reciprocal. So secant is the same thing as 1 over cosine. So in your calculator, you're going to type 1 over cosine and then put 1.2. So let's do that together. So 1 divided by cosine, 1.2. And you get 2.7597 for that guy. Okay? So any questions on using radian measure in your calculator and degree measure? Think we're okay? So here's something you got to be careful with. If you take a test, well, when you take a test, if something's in degrees and you type it in and your calculator's in radian mode, you're going to get some weird numbers. Okay? Vice versa, same thing. So please be careful. One of the very first things I do when I'm approaching trig problems is I look at the mode on the calculator to make sure is it in the right mode. Okay. Last thing, applications. So let's try an application with it, and then we're finished. Okay. Let's talk about angles of elevation and depression. This should look familiar from algebra or from geometry, I will say. There's my eyeball. Okay? So here's the deal. I need So here's the plan with this. Okay? So when you're looking outward, so here's me, there's my eye level. Okay, angle of elevation is from your eye level. Let's say I'm looking at that tetrahedron, that little snowflake right there, that's in the 3D shape. Okay, if I want to look up to that, my eye level changed, right? So from straight ahead to there, that we call my angle of elevation. Okay? Does that make sense? So, angle of depression is the opposite. So let's say I'm looking from here to the bottom of my chair. So that change from eye level to here, we call my angle of depression. Okay? Questions on the difference between those? Sound good? So let me go ahead and draw it for you up here. So here's my eye level. Okay? And again, let's just say there's some object up here. Cool. So you look it upwards, so this is angle of elevation. And then same thing, if there's some object down here, okay, that change from eye level to the bottom is my angle of depression. Okay. Now, the nice part is, drawing all those lines, can you see me like just drawing a nice vertical line down to here and same thing to this level and creating a right triangle? And then we can use that to find some side lengths, right? To figure out some measurements that we need. So that's perfect. So let's try it out over here. So our last example. From his hotel room window on the 6th floor, Alex notices some window washers. High above him on the hotel across the street. He quickly estimates the buildings are 50 feet apart. Smart guy. It's pretty good if you can gauge it from eye level. You're like, it's about 50 feet. That's what you can. The angle of elevation is 80 degrees, and the angle of depression is about 50 degrees. Okay, so I got two questions. Part A is, how high above the ground is the window of Alex's hotel room? Okay, so that's part A. And then part B, how high above high above the ground, I couldn't read my writing for a moment, are the workers? It's picture time. Draw a picture. It's very nice to draw one just to get your thoughts down, just see what's happening, okay? So I'm going to draw two buildings. There we go. Just like that. Okay, let's use some information here. So he's on the 6th floor. So I don't know, let's say he's here. And he's amazed, like, oh my gosh, there's people across the street. Okay, 50 feet is between the two buildings. And the workers are up here. And they're working, so they're not happy. There we go. I did say workers, right? This means you want more. Poor guy can't work alone. There we go. He's not happy either. Okay, we got our workers up there. Now, let's go ahead and draw some angles. So here's his eye level. He's looking straight ahead. Okay? So from his eye level, he's looking up to the workers. Okay, so that angle was 80 degrees. And what I'm going to do is I'm going to put a right angle here because it's going to be vertical with the side of the building there. So there's one triangle I'm going to have where I can start solving for some things. And then he's looking down at the bottom of this. So, boom. And that's angle of depression at 50 degrees. And again, I'll put a right angle on the other side there just to show a nice little triangle. Now, part A and B, you want to figure out how high Alex is and how high above the workers. So I think we can agree that this height right here would be how far up he is, right? So let's call that, I did like little h. So I'm going to put up here, h would be Alex's total height. And then I'll put w right there, okay? So w, let's see, would be the height of the workers. Now it's not the total height of the workers because it's only from where Alex is above. So the height of the workers from Alex's window. Okay. If I want to figure out the total, well, we're going to have to do something a little extra at the end. So let me just pause for a moment. Any questions on how I drew the picture and drawing the stuff there? Awesome. All right, let's do part A first. So how high above is the window from Alex's room? Okay, so we can do that. So here's this triangle right here. Okay. Now this 50 feet could be translated up to here, right? So that's the same thing as 50 feet. And notice that here's my angle. So if this here is 50, this is h, that's my hypotenuse. I'm only using these two sides. And in relation to the angle, this would be adjacent to it, this would be opposite. Adjacent and opposite, I think that's tangent, right? Tangent uses those two sides. So what we have here is tangent of 50 degrees equals h over 50. Okay. Now, by the way, you could have done this instead. If you want to use cotangent, you can use cotangent as well, right? So just keep that in mind. If you don't want to use tangent, you can definitely use cotangent at 50 degrees and work with that. So solving for this, I don't know, 50 to both sides, huh? That gets h by itself. So on this side, we get 50 times tangent of 50 degrees. On the other side, we just get h. Please be careful. Do not do this. Okay? The reason why I say don't do that is because it looks like you're multiplying the angle by 50, not tangent by 50. Big difference, okay? If you type in the calculator that way, not good either. Because your calculator is going to say, yeah, you're multiplying this by 50, then you take a tangent of it. So keep the number outside of the trig function. Okay, typing it in, we get roughly 59.6 feet. Okay, so that's how far he is above the ground. Now, part B. I gotta find the total height of the worker. Now, here's what I'm thinking. If I find the height of this, I just have to add his height, right? And then I get the total height that it is from the ground. So again, let's find W, and then at the very end, we'll add H to it, which we know what H is already. So this is 50, that's W. There's 80. I think we're using tangent again. How about that? Because this is the opposite side, this is the adjacent side. So we're gonna do tangent of 80 degrees, okay? Is gonna be equal to W, oops, that's not 80, there it goes. W over 50. We lucked out, it's gonna be the same computation here, just different angle. We're gonna multiply both sides by 50. So 50 times tangent of 80 degrees equals W. Again, make sure you put the 50 on the outside. Okay, and we get 283.6 feet. Now I'm not going to circle the answer because that's just from Alex's window to where they're at. If I want to know what the total height is, I got to add Alex's height from the ground up. So I'll put here total height, so we know why we're doing this. So it's going to be the 283.6 plus the 59.6, so 342.2 feet. So that's how high up the workers are. Okay? So if you have protractor, well, now if you have a, what do they call those, clinometers? Yeah, you can use you can actually, what you could do, it's easy to make. You could take a protractor, hang a small little weight to where a string is, and then use that to measure, because that weight of the string will tell you exactly what the angle is. And you can do this yourself calculation-wise. So, alrighty. Hey, that's part 2. Any questions on that? Okay, you guys are awesome. Good job. Here's your practice for tonight.
Doing most
Yeah.
That's supposed to be 343.
Is that 343? That copy's down low. Oh my gosh, it is. Thank you.
My calculator's in there.
Sorry guys, it's 343.2.
Yeah, my calculator's in there.